Today I'll be deriving the rotational inertia of a sphere, where the axis of rotation is right in the center of it, and I'll be using a similar method in my previous video, where I split up this sphere into multiple hollow cylinders. So we're trying to find the sum of all the m squareds. So the first thing we're gonna do is, like I said, split it up into multiple hollow cylinders, and we're gonna try to find the volume of each individual hollow cylinder with respect to its distance from the axis of rotation. Alright, so just to give a diagram, this would be a hollow cylinder. So let's cut this cylinder here and let's extend it so it becomes a rectangular prism. Alright, so we know this distance right here to be dr, this distance to be some height, and this distance to be 2 pi r. Because you can visualize this, if we if we extend it to a rectangle, the length would be 2 pi r and the height would just remain the same, and in this distance from here to here we will just call it dr. Now the smaller dr gets, the more accurately we can split this up into a rectangle, because just imagine like a thin piece of foil, a rectangular foil made into a cylinder, and you can just undo the cylinder and you get the same piece of foil. Alright, so we know the volume of each individual cylinder to be, well, 2 pi r h dr, but we have a problem. We have two variables, so we can't integrate this. We're gonna have to find a formula that tells us h in terms of r. So let's do exactly that. So let's take this sphere and plot it on an xy graph. Okay, this is an imperfect sphere, but whatever. So we know x squared plus y squared equals big R squared, and big R squared is the total radius of this sphere. Alright, and let's say the axis of rotation, we flip this sphere around, so we get that the axis of rotation is on the y-axis. So the axis of rotation of the sphere is on the y-axis. Now, what would h be? So let's inscribe a cylinder here, because originally the cylinders, we're looking at the cylinders from the top, but when we flip the axis of rotation around, now we're looking at the cylinders from the side, and they look like rectangles. And we know this to be h. Then hence, h would just equal 2y. This is y, and this is y. But what is y? Well, here to here we get that y equal root the big radius squared minus x squared. But what is x? Well, x just equals r. So I'll show you. This right here is r. This right here is x, right? From here to here is x. But likewise, if we were to flip the cylinder over again so that the axis of rotation is pointing at us, so this would be r, right? But this r is the same as this x, so hence x equals r. Because when we flip it over, the cylinder's top would be that r part. So this is the cylinder. So this r here, or let me draw it better. So that r there would correspond to this distance x. So hence y equals root r squared minus r squared, and hence h equal 2y, 2 r squared minus r squared. And now we can integrate. So we get the volume equals 2 pi r times 2 r squared minus r squared times dr. And now we want to find, or actually we're not ready to integrate. Now we have to find the individual masses for each of the hollow cylinders. So mass equals rho times volume, where rho is density, right? And rho would just equal total mass over 4/3 pi, or total mass over total volume. So hence that's what it equals. we multiply rho with this, and we get that mass equals rho 2 pi r2 r squared minus r squared dr. And finally, we're trying to find the sum of all the mr squared, not the total mass. So we need to, take an integral from 0 to r, rho 2 pi r 2 r squared minus r squared, and we need to add to the end of this a further r squared. We're trying to find the sum of mr squared, not n. All right, let's take the constants out. So you get that rho 4 pi. I multiply these two together, and we get the r cubed r squared minus r squared, and we need to solve this using u substitution. So u equals r squared minus r squared, and hence du would equal negative 2r times dr, and hence r squared would equal, let me think here, r squared minus u, and dr would equal du over negative 2r. All right, so let's convert this. So let's ignore these constants. We need to remember these, but let's ignore it. So we get that the integral of, well, r cubed times root u times du over negative 2r, or naturally these r's just cancel out, get that equals r squared times root u over negative 2 du, and like I said, r squared equal r squared minus u, and this r squared is a constant, so this would just equal r squared minus u root u du all over negative 2. Let's go to the next page. Remember this, and we're gonna distribute this root u to both these terms here. So we get that an integral of r squared root u minus u to the 1.5, I think, over negative 2 du. So I distributed this root u to both this term and that term. All right, and now we can actually take an integral, and we just get this u to 1.5 over 1.5 minus u to 2.5 over 2.5 all over negative 2. And we want to convert this u back into r squared minus r squared, because we don't know our constants in terms of u. We don't know the limits of integration. So if we convert it back, so for reference, r squared minus u equals that. So r squared minus r squared 1.5 over 1.5 minus r squared to 2.5 over 2.5 all over negative 2, and constant from 0 to r. All right, so let's consider r first. If we plug in r here, this term just becomes 0. But if we plug in r here, then let me think. Yeah, this term will just also become 0. So we should not consider r, because if we plug it into this term will become 0, because it will just become r squared minus r squared, and this. And it's the same here. So this becomes 0 and this becomes 0, but let's consider 0. If we plug in 0 here, then this would be non-zero, because that would be just r squared in this parentheses. Plug in 0 here, it's the same case. So we only need to consider 0. But since this is the bottom hand, we need to put a negative sign, and r squared minus 0, so it just becomes 1.5 for 1.5 all over negative 2 minus r squared 2.5 over 2.5. And let's simplify this. We get that all in here, that negative, this becomes r third, so r fifth over negative 3 plus r fifth over 5. So I multiplied 1.5 to negative 2 to get negative 3, negative 2.5 to negative 2 to get 5. All right, and we just get, if we plug in this negative sign, r5 over 3 minus r5 over 5, and if we, rewrite this, so this becomes 5 over 15 minus r5 over 15, 2r 5 over 15. Now, remember, we left out this part, so we need to multiply pi, rho for pi here, all right? And let's convert rho back to what it originally was. You see here, rho was total mass. Where did I write rho? Oh yeah, total mass over total volume. So m over 4/3 pi r cubed times 4 pi times 2 r 5 over 15. And this just simplifies down to 2/5 pi r squared. And here's the r third and the r fifth. These cancel out, so this becomes 2. This becomes entirely eliminated. Pi's cancel out, 4's cancel out. Let me think. 3 cancels out with that to get 5. And we're just left with m r squared, 2/5 pi r squared times m. Whoops. And no pi. Sorry about that. 2/5 m r squared. The pi's got canceled out, but the mass remained the same. All right. Okay.